this is going to come as a shock to you, but most students don't like completing the square. It's just, they don't feel comfortable with it. So somebody at some point realized if I complete the square in general, I can find a vertex formula, much like we found the quadratic formula. And so if you complete the square in general, so I'm going to show you a really convenient formula then. So let's say you have f of x, kind of the generic standard form, equals a times x minus h squared plus k. Oh, sorry. Let's say you start out, we're going to end up with that, but let's say you start out with the multiplied out form. F of x equals ax squared plus bx plus c. And let's say you complete the square just like we did in the last problem, but we have generic a, b, and c for our coefficients. I'm not going to bore you with the details like I did on the quadratic formula. It's very similar to that, deriving the quadratic formula. If you do that, you get a times, of course, x minus h, but you get h in terms of a and b if you do that. In fact, so you complete the square, the dot, dot, dot means lots of work. Complete the square to put it in standard form. And if you do that, the thing inside the parentheses becomes x minus, I'm going to put it in red, inside red parentheses. The thing you end up subtracting from x is negative b over 2a. So you do all the symbolic manipulation, and that guy is negative b over 2a. You also get k, the second coordinate of the vertex, in terms of a and b, but it's a mess, and you don't need to remember it. So I'm not going to do that part. But that's what happens. You can just trust me, or if you want, you can go home and just for fun try it yourself. You don't have to. Just kidding, right? It's only if you really want to. So what does that mean then? Well, it means that h, the thing we normally call, let me use a different color. The thing we've been calling h then is negative b over 2a. And so we've got a formula for the first coordinate of the vertex. So this is the vertex formula then. Okay, the first coordinate of the vertex is negative b over 2a. That's the part you should memorize. The second coordinate, okay, if you have a first coordinate and you have a formula for your function, you can plug in the first coordinate to get the second coordinate. So it's just f of, function notation, f of negative b over 2a. That's k. Okay, so in other words, h is negative b over 2a. That's the vertex formula. And then you get k just by plugging in whatever negative b over 2a is into the formula, into the parabola formula, the quadratic function, in other words. That's handy because then you don't have to complete the square like we did in the last example. So now I'm going to do this using, instead of completing the square, I'm going to use the vertex formula. So find the vertex. Okay, h is negative b over 2a. Can you fill that in for me? That's the formula. It's the usual, the coefficient of x squared is a, the coefficient of x is b, and the constant is c. So fill that in for me. What do you get? Okay, the b is negative 16, so the opposite of b is 16, divided by 2 times 2, which is 4. So what do we get? 4. Man, that's easier than completing the square, isn't it? We still need k, though. So if we know now remember, h is a first coordinate, right? It's an x value. It's a particular x value. So if we know a particular x value is 4, how do we get the corresponding y value? You just plug it in the formula. K is going to be f of 4. And so you get, okay, plug it in. 2 times 4 squared minus 16 times 4 plus 23. Okay, what's 2 times 4 squared? Yeah, it's 16 times 2, 32. Minus 4 times 16, So 32, so it becomes 32. This guy is 32 minus 64. 16 times 4, that's negative 32, isn't it? Plus 23. So think of it as 32 minus 23, and then stick a negative in front of it, right? So negative, because the negative outweighs the positive. So what is that, negative 9? So what's the vertex? 4, negative 9. All right, so let's plot that point. Go over 4. 1, 2, 3, 4, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm extrapolating a little bit. So there's my vertex. Does this thing open up or down? I forgot to ask you that on the last one. It opened up, right, on the last one? How did I know it opened up? Because A is equal to 1, so you get a smiley face, right? This one opens up. The next one will open down just to contrast it. So it opens up, so we can expect a smiley face. We just need to plot one value to get a decent graph here. What x value would you like to plug in? Something close to h, which is 4. 3. Yeah, we don't get too creative here. So let me back off the view a little bit. Let's plot one value, x comma g of x, and you said let's plot 3. So that means, oh wait, actually it's not g in this case, is it? It's f. The last function was called g. This one's called f. So f of 3. Oh, well, we just plug in the formula. Use your calculator if if you don't feel comfortable with arithmetic, use your calculator. So 2 times 3 squared minus 16 times 3 plus 23, I don't know, 9, 18 minus, what's 3 times 16, 48? Plus 23, oh gosh, what is that, negative 40, negative 30? Plus 23, what does that turn out to be? Everybody agree with that? Okay, so over 3, 1, 2, 3 down, 1, 2, 3, 4, 5, 6, 7. Oh, got to do that in red. Okay, let me zoom back in for a second. So if this point's on the graph and this point down here is the vertex, where's the symmetric point at? Okay, what would the coordinates then of that symmetric point be? Just to make sure you... So 1, 2, 3, 4, 5, right? Because the vertex was at, the h was at 4. So it's got to be 1 to the right of that. So 5 and then same height, negative 7. Okay, that's your symmetric point then, right there. And then just, you don't want to, since we didn't find the x-intercepts, you don't want to go too far up, because you'll start to go off course, because we've only plotted 3 points. If you want a more accurate graph, what do? Plot more points. In fact, plotting the intercepts wouldn't be a bad idea here. I'm not going to have time to do it. How would you find the intercepts, though, the x-intercepts? The y-intercept's easy. What's the y-intercept? Plug in 0 for x. What do you get for y? 23. Everybody look up. I know you're tired. Plug in 0 for x. Does everybody see 23 pops out? Y-intercept is 0, 23. Am I going to plot that? No, that's way the heck off my graph paper. I'm not going to plot that. If I wanted the x-intercepts, though, the x-intercepts would be like, somewhere in there, right? I could plot those and maybe have a more accurate graph that way. Definitely have a more accurate graph. But how would you find them? You set y equal to 0, which means setting f of x is y equal to 0, and then you could use the quadratic formula to solve that.